Hey everybody, it's Ted here, and I got some questions from some of you out there on my channel about IPS alignment. And when you've got a pair of drives that aren't in alignment, it's based on the resolver feedback. So if the drive is physically not aligned when it's installed, the upper is installed on the lower if the lower's not aligned. This won't know it. And what will happen is when you turn the key on, the resolver will self-center the drive if the resolver is self-centered when it's installed, and then the drive will be offset. So a couple things to check is if you have these scenarios, boats in the water, drive the boat, get it up on plane, have the steering wheel centered, let go of the wheel, and it pulls to port or it pulls to starboard. It may drive reasonably straight when you're not on plane, but as you accelerate, the boat may pull to one direction or the other. So if you have the wheel centered and you're driving in a straight line, and then as you accelerate, the boat starts to pull in one direction or the other, that most likely is that the lower leg on one of the drives is off-centered, and that can be easily done when you install it. It's not something that's uncommon. It just happens. Good technicians do it by accident, and then they have to realign the drive when they put it back on. So if the drives are on the boat and the boat is out of the water, you can easily check to see if they're aligned, and I'll show you how to do that real quick. I've got another drive here, and what we're going to do is we're just going to kind of look at the other drive and pretend it's an IPS drive, so you get a look from see what I'm talking about, how to check alignment if it's out of the water. So that would mean one drive is straight and one drive is either towed in or towed out. So let's take a look at that. Okay, if the boat's out of the water, the first thing, we're going to pretend this is the other IPS drive and this is the other one. So these are going to be installed in the bottom of the boat. They're going to be angled down slightly like that, but you'll get the idea in a second how you check alignment. So the first thing we want to do is we want to measure from the very tip of the actual nose cone of the first drive on this side and then the other drive. So we would take a tape measure. You need two people for this, and you're going to measure over, and let's just say, for example, this was 32.5 inches. Yours will be much wider than that, more likely. But let's just say that this dimension is 32.5 inches from nose cone to nose cone, as centered as you can figure it out. So you want to make sure that you get to the very center of that, and that's your best measurement there. The second measurement I'll show you. Okay, the second measurement that you're going to make is going to be from either the bottom of the skeg, if it's not bent, to the bottom of the other skeg, and again from the center of the skeg. So this skeg might be, it's probably 1/8 of an inch thick, just over 1/8 of an inch thick. The bottom of this one is pretty close to that. So that's the dimension, is from here to the bottom of the skeg to the bottom of the skeg, which should be the same as the other side, 32.5 inches. There is a spot right here on the drive, and I'll zoom in on that, and that is where the bottom of the cavitation plate is, and it kind of comes to a point. The problem is the hull might be in the way, and that's the problem with that, because if the hull's angled down like this, you're not going to be measuring that across. But if they were if the boat was a reasonable flat bottom boat, and you could get to that point to the other drive at the same point, then you could measure that. But if the skeg is bent, then we want to come up here someplace and we want to try to find the center of where the back of the exhaust housing is. They have this offset piece of the drive, which is a trim tab. It keeps the drive from pulling in one direction. And the problem with that is that's wider on one side. So you don't want to measure it there if you can help it. You want to try and figure out what the center of it is, and that's why coming down here to the skeg is the best bet. So let's zoom in on this point to show you. So this is the point that I can see right here, which is about the center line of the drive housing. And as you'll see down here, that side's much wider than this side. So that would be hard to measure the very center of it. If you went down to the bottom, then you measured in that dimension, whatever this dimension is, and then the width middle of that, then get to the center of this point about here. So you want to be from here and then measure over to the other drive. Do Okay, this is a perfect timing for me to kind of cover this because I'm getting geared up for an IPS class. And whether it's an IPS 1, it's an IPS 2, it's an IPS 3, you still have the same functionality and you still have the same way of checking drive alignment in them. So let's get started on, I've got this kind of set up to show you the pieces and parts, and we'll go over the process of how to actually check to see if the drives are in alignment. Okay, where we want to start is on the top of the IPS unit, you have the sticker. And that sticker basically says if you have the emergency tool and you want to self-center the drives, for example, let's say that one of the drives, the motor dies and the drive is offset at an angle. Then what you want to do is you want to take that drive that's offset and you want to crank it all the way to one side or the other where it stops. And then what you're going to do is you're going to take that tool, you're going to take this screw out, and you're going to put that tool in there. That, by the way, is a 10mm socket, fits it if you do not have the tool. And I don't have the tool, I can't find it. I've put it someplace really good. So we're going to use a ratchet for this. So then what you would do is if the drive was offset and you're stuck in the water, the drive's stuck in that position, the other drive is straight, shut the engines off, take that screw out, and then turn this until the drive stops. Hopefully you go in the right direction, because otherwise you're going to go all the way over to the other side. But wherever you feel it stop, where it just stops, then what you want to do is you want to turn it 75 turns back, and that will self-center the drive. Put the plug back in, the drive will not move obviously, and then you can drive the boat with the other engine, and you might be able to start this engine and shift and throttle it at least, so that you could steer the boat by changing the throttle on your engine on one engine, and that would decrease the RPM of this engine, but the other engine is a higher RPM, so the boat would turn to port. Likewise, if I increase this RPM and decrease this RPM, the boat would turn to starboard. So that's your emergency setup right here. They put this in the book and they tell you about that. So the next thing I wanted to do is to show you, okay, we know how this works, but let's look at the pieces inside underneath this unit and how that attaches to the midsection. Okay, this is the upper gear case and it's been removed. It's on a stand that we service them in. This is how we work on them. And this is it upside down. All right, so this is the gear that actually moves the drive, and we'll look at the quadrant in a second that's actually bolted to the lower part of the drive assembly. And then on the other side of the shaft, there is a double planetary assembly. It's got 3 small gears, a large gear on the outside, and then that planetary attaches to another planetary gear set with which the motor itself drives. And this is the gear on the other end that faces up this way in that shaft. So this gear is moving very quickly, and it's a gear reduction. It's the double gear reduction that drives the electric motor that drives this gear. So now on the quadrant side of it, what we have is we have the actual quadrant, and this actually bolts onto the drive itself. This would be the lower unit section, and this piece is attached to that drive, and this would fit something like that, okay? And that's how that has to be when it's centered, when it's attached to the drive assembly. So basically what you have is this is bolted to the lower unit. There's a drive coupler that's splined to this, that's splined to the lower unit. And then what happens is as the electric motor spins very quickly, that gear moves, and this moves like this, and it moves the gear. You've only got about 20, 22 degrees maximum turn in either direction. So let's go ahead and let's look at the resolver portion, this assembly, and then the drive gear assembly. So the drive gear assembly has to be centered. The resolver has to be centered. If the resolver is installed correctly, then when you start the drive up, what happens is no matter where the drive was shut off, it will self-center itself based on this resolver. So I'll show you a couple of pictures out of the book on how you know this is aligned and how you know the drive is aligned. Okay, so step 1 in the book, as it says here, you have to make sure that that resolver is centered. All right, so that resolver has to be centered, and do that with a straight edge. So now what the technician needs to do is he needs to make sure that the drive is centered, and you can move the drive back and forth, okay? you can swivel it back and forth while it's in the boat. If the boat has the drive and it's in the bottom of the boat or an angle, the bottom of the boat isn't flat, then the drive's gonna, be out like this on this side and out like that on the other side. And it is very easy for that drive, if it's, stationary and you move it a little bit and you're trying to get it in the right position, when you go to put the upper portion on top of this, you can't see that quadrant anymore, and the drive can move ever so slightly. So let's see how close that has to be when we check it. So this is going to be upside down. Basically what I'm going to show you is I'm going to show you the drive is upside down. And these, there's a locating pin here, and that locates this on the drive. So this would be, the lower unit is upside down facing the sky. All right, this is attached to the actual lower unit, and you can move this. So basically what you can do is you can do this with a drive. Now, when you drop the upper on the lower, right, if you don't get it perfectly centered, your resolver centered, but if the drive is not perfectly centered fore and aft, let's say it's off just a little bit, then how you would know that is you wouldn't be able to see it. But if you've gone underneath the boat, you could see the drive was not centered, it would be off. Now, how far off is it? We can just simply say, okay, how many teeth are there? So this side is 1, 2, 3, 4, 5, 6 to the center. This one is 1, 2, 3, 4, 5, 6, 7, 8 to the center. If we were off that one tooth, you're off by 10, maybe 15 degrees. I don't know what that angle is. It's not a lot, but it's visual underneath the boat. But if the boat's in the water and you put this assembly right side up, you cover all this up. You can't see it when you're putting it on there. So it's really imperative that this stays exactly straight forward when you're putting this on. Now remember, this whole assembly can be mounted on the boat at an angle like this. My whole training aid is in the other building. It's in a shipping container outside, and I'm waiting to pull that stuff out to train this class this coming term. If I get a chance, I'll make another video of just that midsection and how it can rotate and what this looks like when it's bolted on there. But it's very easy for a technician, even good technicians do this, is they get it all set up and then this just rotates ever one tooth and then they drop the upper on the lower. And you can't really see it. If you put blocks underneath the lower unit section, as you drop this down, you can line the splines up for the drive assembly. And then it would be possible with a mirror and a flashlight maybe to look in here and be able to count the teeth to make sure you are actually lined up on number 7, I believe. So if I got that straight, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 teeth. That's the center one, and that's the way it's all go together. So the drive has to be centered, just like this, when you put the upper on the lower, and your resolver has to be dead center through that line, like that, okay? This is something that only a service technician should work on. Resolvers are finicky. You can damage them real easy. When I teach in the class, I'm right there with the students, making sure when we work with this, they don't have a chance to mess it up, because they can very easily ruin this component, and it's not cheap. Okay, so you don't know which drive's crooked, unfortunately, because they're in the boat's in the water. So this can take a little bit of time. So what you're gonna do is you're gonna read this sticker. That's the first thing. And it says, if everything's perfect in the drive, the engine's shut off, when you shut the drive off, the SUS unit here is programmed so that when it goes through its shutdown sequence, it centers the drive. So go to the first drive, pick a lucky number. If you've got triples, you got quads, or you got twins, obviously you got to check hopefully the first drive that's incorrect. So take this screw, unscrew it, get your magic little tool, looks like a little handle like that. And then what we're gonna do is we're gonna take our 10mm socket, because I don't have the tool. And what I'm gonna do is I'm going to turn this 75 turns. Now, if I'm turning it and I go all the way and I'm moving clockwise, I'm just showing you what happens is if I'm turning this and turning it and I get to 60 turns and it suddenly stops, well, that means it's not centered. I should be able to go to 75 and it stops. So then what I can do is I can go back the other direction and I can turn it the other direction, right, all the way until it stops. And if you counted that, then that would be 75 plus 75, which is 150 turns. Then you'd know you went through the whole sweep of one side, okay? So whichever direction you start, and I always say go clockwise if you want. So what I'm gonna do is I'm gonna turn this 75 turns, and it is centered on the unit itself. If I look underneath here, I can tell it's centered. And what I would do is I would simply start turning this. So 1, 2, 3, 4. That's 70, 71, 72, 73, 74, 70. What I'm going to do is I'm going to flip it over and we're going to take a look and see what it looks like. Okay, so here's the resolver, and the resolver is well off the mark, but notice it's not all the way to the end, right? It's here. Now, the reason for that is because the quadrant could only go so far. So I'm going to put the quadrant on there and show it to you where it would end up stopping. It couldn't go any further. So if we rolled that all the way this way, okay, then the quadrant would have done this, and then it would have bottomed out right there. You couldn't go any further than that, okay? So when you get to here, the last tooth, that's 75 turns of the upper shaft. This shaft doesn't turn, obviously, 75 turns. That's their gear reduction for 7 teeth to move 75 turns on the top. That's the gear reduction there. So if the drive stops before you get to 75 turns, you got lucky because you have been on the original, let's say, 1, 2, 3, 4, 5, 6 teeth like that. So you would have been here and it would have gone all the way to like 60 turns, and then it would have stopped. It would have locked right up. That means that that drive is off one tooth, okay? Now you can go back 75 turns. If you did that, you think, oh, well, why don't I just turn this back to 75 turns? And then we're dead center there. So 1, 2, 3, 4, 5, 6, 7, all right, and then we're on the center, 1, 2, 3, 4, 5, 6, 7. But the problem with that is the drive is still going to be there. That's not centered. And the resolver is not centered on this. The resolver would be centered at 75 turns. It would be in perfect in line of this, but this is still off a tooth. So you have to take the upper off. There's no choice. The whole thing has to, be unbolted and take it off. These are heavy. These aren't light. These can get your fingers crushed in here real easy. I don't recommend that a homeowner come in here or somebody that owns the boat that comes in here and tries to do this. I would say it would be a good idea to have a certified Volvo technician come in here and do this. They have the tools to do it. They have the knowledge to do it. Some of them make mistakes. It does happen, but this is so you understand how it's rectified. So I'm going to go back 75 turns, and then we're going to see where that resolver is. So I'm going to go back the other way. We're going to go counterclockwise 75 turns. So I'll speed this up, but I'm going to do it 75. So 1, 2, 3. 3, 74, 75. That's why you kind of want a fixed tool. If you're going to do this and you don't have that tool, I'd recommend you go like any place, Harbor Freight tool, wherever, and get yourself an actual breaker bar, one that doesn't ratchet, and then attach that to the 10mm socket. And that way, if it does slip out of your hand, it doesn't go like that. That just is a pain. So, all right, I'm gonna flip it over one more time and let's see if we get lucky and I got the ratchet pretty close to the center of that resolver at 75 turns. All right, I'll show you. These things aren't light. This is on a stand, custom made, that I made. This is my own design. Works really well for in the class. Not having them attached to the floor is nice to have a mobile. The other thing I did was I made these pipes the same diameter as our drive stands over here, so we could take the drive stand out and actually put this into the drive fixture on the table, and that really stabilizes it. One of the engineering things I like to do here, so out of the way. And man, I'm like, I think my little ratchet thing's on the money. Okay, so that was my 75 turns back. And let's see how that looks through the center. I think it's, because I'm going to the center line hole, to the center line of this, not the tooth. I'm not worrying about the tooth. But again, if we count the number of teeth on the resolver too, they're split on the sides here. So we're going to count from this flat 1, 2, 3, 4, 5, 6, 7. And then on this side, we should have 1, 2, 3, 4, 5, 6, 7. Yep, right in the center. So I would say that's about as good as it's going to get. All right, so that's how this gets installed first, and then how you have to make sure the quadrant is aligned. Okay, so I hope this video helps you understand how to check the alignment on a drive if it's not centered when it's installed on the boat. Out of the water, it's an easy process. Just do your measurements. If they're off, then you know the drive isn't centered. One drive will always be centered if it's installed correctly. The worst case scenario would be that neither drive was aligned when it was put together, so they're going to both be off some weird direction, and that would be just, I can't imagine it happening, but that has. Probably from somebody that doesn't really know what they're doing working on it. Unfortunately, that can happen. But if the drive is straightforward, then again, that sticker right there tells you right on the top of this that if you put that tool in and you turn that tool 75 turns, it should stop. If it doesn't stop and it keeps going and you go to 90 turns and then it stops, then that means the drive was this way and you had to turn it more. If you turn it 60 turns and it stops, then that means the drive was this way already, and that would be the drive that you have the problem with. If you have one drive is 75 turns and it stops, that's not the drive you have a problem with. It's when you're in the water, you can't see it. So you have to go ahead to the other drive and verify that that drive doesn't turn exactly 75 turns. Don't forget to turn it back 75 turns before you put the cover back on, okay? So I hope you liked and enjoyed the video. I hope it was educational. We do have IPS. I teach it in this class upcoming in our 7th term here. So we're looking for students to come into the program to go out there to work on these, you know, expensive large vessels, yachts. We can fill hundreds of jobs across the United States. There's tons and tons of companies looking for people. So if you know anybody or any young guys that are interested in getting into the marine field, you know, there's a big opportunity out there. So I hope you liked the video. Please hit that like and subscribe button, and I'll see you in the next one.